In this video, we will be looking at systems of inequalities. By the end of this lesson, you should be able to solve a system of linear inequalities in two variables graphically. So let's take a look at when you may see this. In situation number 1, it says during the summer you want to earn at least $200 per week. You earn $10 per hour working as a lifeguard, and you earn $8 per hour working at the grocery store. You can work at most 30 hours. We notice here that this looks similar to some of our systems of equations, but the difference here is I notice I have my inequality words here. At least, which if we remember means greater than or equal to, and at most, which if we recall means less than or equal to. So first, let's set up our variables. So we're looking at two things, working as a lifeguard and working at a grocery store. So let X equal my hours as a lifeguard, and Y will be hours at the grocery store. So we're looking at those both in hours. So let's set up this inequality. So I know I want to earn at least $200. So let's look at our equation that is related to how much money I will earn. My first equation has to do with the money that I will earn. So I'm going to earn $10 per hour as a lifeguard and $8 per hour at the grocery store in a week. Now I want to earn at least $200. If you notice, all of these coefficients and constants deal with money. So that allows you to kind of see how you want to set up your inequality there. My next equation has to do with my total hours. So if I look at my total hours, I remember that I want to work at most 30 hours. So my hours as a lifeguard and my hours at the grocery store can be at most 30 hours. So I can write my hours as a lifeguard plus my hours as a grocery store have to be at most 30 hours. So this entire equation deals with hours. My hours plus my hours equal or less than or equal to my 30 hours. We'll come back to this system a little bit later. Let's take a look at how we would solve a system of inequalities. If we remember with all inequalities, there are an infinite number of solutions. So we can only solve by graphing. When we talked about equations, we also had substitution and elimination, but inequalities we can only graph. So let's start graphing our first one. So if we remember just graphing our equations, we always had to look at our slope and our y-intercept. That doesn't change here. The slope of this line is 1/2 and the y-intercept is 2. So I'm going to go ahead and start at 2 and go my slope 1/2, and I'm going to continue in the other direction as I did for my systems of equations. And now it's not an equation. I have to look at my inequality. I have less than, which means I have a dashed line, and I'm going to shade down. So here, I'm going to dash the line in between and shade down, shade below this line. Doesn't have to be perfect, just shade below. I'm going to take a look at my next equation. Same thing, I'm going to look at my slope. M is equal to -2/1. B is equal to 5. So I'm going to go up 5, 1, 2, 3, 4, 5. And then I'm going to travel my slope down 2/1, down 2/1, down 2, down 2/1, down 2/1. And I want to consider my sign. Again, greater than or equal to is going to be a solid line, and I'm going to shade up. Okay, so I'm going to draw a solid line through these points, and I'm going to shade up. If you notice, we have an overlap here, And that is our solutions. All solutions are in the overlap of the two graphs. So this is for systems of inequalities. My solutions are in the overlap. So we're going to take a look at our next question here. Which of the following points are solutions to the system of inequalities? Circle and plot them in the graph. So what we're going to do is take a look at, we want to see which of these points falls into that solution area or where the overlap is. So let's first take a look at the point 4, 1. So I'm going to graph 1, 2, 3, 4. Up 1. I notice it's in the shaded region of both the pink and the purple. So that is a solution, the point 4, 1. Negative 1, 0 is right there. And I notice it's in the shaded region of our first graph, but not of the second one. So that is not a solution. The point 2, 1 over 2, up 1. I land right on my solid line. I notice that it's in the shaded region of the pink and on the solid line. That will be a solution since it's on a solid line. 2, 1 will be a solution. 0, 5. 1, 2, 3, 4, 5. I notice it is on the solid line, but this one is not in the shaded region of the pink. So 0, 5 is not a solution. And lastly, the point 4, 4. I go over 1, 2, 3, 4, and up 1, 2, 3, 4. And I notice that I'm in the shaded region of the purple, and I'm on the pink line, but notice that it's a dashed line, so 4, 4 is not going to be a solution to this inequality. Let's take a look at another example. Example 2, our two equations, our first one says x is less than 3, and our second one says 2x plus y is greater than or equal to 2. If I notice here there's only an x, that's going to follow my special kind of pattern, my VUX pattern. If you remember, that's a vertical line. It's an x equals, or in this case, an x is less than line. So I'm going to come over here to find 3, and I am going to put my line through that. But I need to determine first what kind of line. I have less than, which means it's dashed, and I will shade down. So I'm going to put my dashed line here. Now in this case, with a vertical line, I can't really shade down, but I shade to the left. If I think about where my numbers are, I get bigger numbers out here, 4, 5, 6. My smaller numbers, or my numbers less than, are out here. So my solutions are going to be all to the left. Any solution to this inequality is out here to the left. Okay? Let's take a look at our second equation, which is in standard form. I need to solve for y first before I can graph. Subtract 2x from both sides. Y is greater than or equal to negative 2x plus 2. Again, we need to remember to identify our m and our b when we're in slope-intercept form. My slope is negative 2 over 1. My y-intercept is 2. I'm going to start at 2, go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and continue my other direction, up 2 and to the left 1. Now again, I need to pay attention to my inequality. I have greater than or equal to, which means it's a solid line, and I'm going to shade up. It's a solid line because I have that underline there. So I'm going to draw my line through here, and I'm going to shade this one up. You notice I overlap in this region here. That's where all of my solutions will be located. So let's take a look at my points here. Which of the following points are solutions to the system of inequalities? Same thing, we're going to circle and plot them. 2, 2. Right 2, up 2. That is in the region where they overlap, so that is a solution. 0, 2 is right here. It's on a solid line, so that is a solution. 3, 0, 1, 2, 3. lands on a dashed line, so that is not a solution. 3, -4, 1, 2, 3, down 1, 2, 3, 4, is on a solid line, but also on the dashed line. And the dashed line is going to make it not a solution because it will never be true. Lastly here, 4, 1, 1, 2, 3, 4, and up 1. That one is only in the purple or in my second equations region, so that one is not a solution. Please make sure you bring your notes with you to class. You will continue to work on these together. We'll work on some of the word problems and continue to practice systems of inequalities.